Imagine sending a message into the vast cosmic ocean, not in words but in proof that we exist. This is the story of the Voyager missions, humanity's emissaries to the cosmos. Launched in 1977, Voyager 1 and 2 were more than robotic probes, they were our curiosity cast into the unknown. Their mission: explore the giant outer planets, Jupiter, Saturn, Uranus, Neptune, and then go further. Each Voyager carries a golden record, a gold-plated copper disc with sounds and images from Earth, greetings in 55 languages, and music from across cultures. It's a hopeful gesture, a message to any distant intelligence that might one day find our travelers. The Voyagers are marvels of engineering, built to survive deep space and equipped with instruments to see and feel the universe. They were launched on powerful rockets fast enough to escape the sun's gravity and head for the stars. Their journey is not just scientific, it's cultural. They represent our ingenuity, our art, our music, and our drive to explore. The Golden Record is a testament. We were here, and we reached for the cosmos. The Voyagers are the first human-made objects destined for interstellar space. Their story is our story, a tale of reaching beyond our world. As they left Earth, they carried with them the hopes of a planet. They are our message in a bottle, cast into the cosmic sea. And their journey has only just begun. The timing of the Voyager missions was a stroke of cosmic luck. In 1977, the outer planets aligned, a rare event that happens once every 176 years. This allowed for the Grand Tour. A single spacecraft could visit Jupiter, Saturn, Uranus, and Neptune, using gravity assists to slingshot from one to the next. Voyager 2 launched first on a path to visit all four giants. Voyager 1 followed, targeting Jupiter and Saturn, then veering toward interstellar space after a close look at Titan. Gravity assists were crucial. Without them, the journey would have taken decades longer. NASA's mission planners charted a course with unprecedented precision. The Grand Tour was a mission of a generation, an opportunity that could not be missed. Engineers built the Voyagers to last, with redundant systems and robust technology. Their launch marked a new era. We were no longer just observing the outer planets, we were going there. For the first time, we would see these worlds up close. The alignment made the impossible possible. The Voyagers set out, ready to change our understanding of the solar system, and they did. The Voyagers' encounters with the planets were spectacular. In 1979, they reached Jupiter, sending back images of its turbulent atmosphere and the Great Red Spot. They discovered active volcanoes on Io, the first seen beyond Earth, and hints of a subsurface ocean on Europa. At Saturn, they revealed the complexity of its rings and the thick, hazy atmosphere of Titan. Voyager 1's flyby of Titan sent it out of the solar system, while Voyager 2 continued alone. In 1986, Voyager 2 reached Uranus, a pale, tilted world with faint rings and a bizarre magnetic field. The spacecraft operated flawlessly, even in the cold, dark reaches of space. In 1989, Voyager 2 arrived at Neptune, unveiling fierce winds, the Great Dark Spot, and geysers on Triton. Each encounter rewrote our textbooks and revealed worlds we'd only glimpsed as points of light. The Voyagers discovered new moons, rings, and phenomena at every stop. Their images became icons of exploration. After Neptune, Voyager 2, like its twin, was flung toward the stars. The planetary mission was complete, but their journey was far from over. The solar system had been transformed from mystery to reality. After their planetary tour, the Voyagers began a new chapter, the Voyager Interstellar mission. Their goal: explore the edge of our solar system and cross into interstellar space. First, they had to pass through the heliosphere, the sun's magnetic bubble. For years, they measured the slowing solar wind and shifting magnetic fields. The edge, called the heliopause, is where the solar wind yields to the interstellar medium. In August 2012, Voyager 1 crossed the heliopause, becoming the first human-made object in interstellar space. It detected a dramatic drop in solar particles and a surge in cosmic rays. 6 years later, Voyager 2 crossed at a different location, giving scientists a richer understanding of this distant boundary. Now both Voyagers sail through unexplored territory, over 20 billion kilometers from Earth. They are the most distant human-made objects, moving at incredible speeds. Their data is our first direct taste of the space between stars. They are silent scouts in the vast darkness. Their journey has taken them beyond theory, into the unknown. The Voyagers continue to send back discoveries from a realm we had only imagined. They are our eyes and ears in interstellar space. Communicating with the Voyagers is a feat of engineering and patience. Their signals, traveling at light speed, take over 22 hours to reach Earth. By the time they arrive, The signals are fainter than a whisper across a continent. NASA's Deep Space Network, giant antennas in California, Spain, and Australia, catches these faint signals. The dishes, up to 70 meters wide, amplify the signals billions of times. The Voyager's transmitters are as weak as a refrigerator bulb, yet their messages cross billions of kilometers. Sometimes only one antenna on Earth can reach them. Every bit of data is precious, a treasure from the edge of the solar system. The ongoing conversation is a triumph of human ingenuity. Each command and reply is a lifeline, keeping the mission alive. Despite the distance, we still hear their faint whispers. The dialogue continues across the vastness of space. The Voyagers are old, launched in 1977, with technology from the early 70s. Each has just 69 kilobytes of memory, yet they endure in the harshest environment. Their biggest challenge now is dwindling power. Powered by nuclear batteries, their energy drops each year as plutonium decays. Engineers have shut down non-essential systems, carefully rationing power to keep key instruments running. Recently, they rerouted power from a safety system to extend the mission's life. It's a race against time. By 2025, only a few instruments may remain active. Eventually, the science instruments will go dark, and only the transmitters will remain. Even a faint carrier signal will tell us they're still out there. But one day, the power will run out, and the Voyagers will fall silent. Their long conversation with Earth will end, yet their journey will continue, alone in the dark. Even with limited power, the Voyagers are still making discoveries. Their plasma wave instruments detect vibrations in the interstellar gas, creating an eerie, ethereal hum. These measurements reveal that the density of interstellar plasma fluctuates, sometimes spiking as shock waves from the sun pass by. The Voyager's cosmic ray detectors measure high-energy particles from distant supernovae, giving us a true sense of the galaxy's radiation. This data is vital for planning future human missions beyond the solar system. Their magnetometers map the interstellar magnetic field, helping us understand how our solar bubble interacts with the galaxy. With every packet of data, the Voyagers add to our knowledge of the cosmos. They are not just traveling, they are reading the story of the galaxy. Each discovery is a new piece of the puzzle. The Voyagers are our only direct probes of interstellar space. Their science continues even as their power fades. What does the future hold for the Voyagers? After their transmitters fall silent, their journey will go on. They will drift through the Milky Way for eons, never captured by another star. In 40,000 years, Voyager 1 will pass near a distant star. Voyager 2 will pass Sirius in nearly 300,000 years. Their legacy is immense. They transformed our understanding of the outer solar system and gave us our first glimpse of interstellar space. The Voyagers are time capsules carrying the golden record, a snapshot of humanity, a message of peace. Long after we are gone, they will still be out there, silent ambassadors to the stars. They remind us of our place in the universe, how small we are and how far we can reach. Their journey is a metaphor for our own discovery, hope, and wonder. The Voyagers are more than machines, they are a part of us. As they travel into the endless night, they carry the legacy of a species that dared to explore. They are our message in a bottle, cast into the cosmic sea. Their story is a testament to curiosity and courage, and as long as they drift among the stars, a part of humanity journeys with them.